In this video, we're going to be looking at how to find the equation of a straight line through two given points. Before continuing with this video, you need to make sure you are comfortable using this formula here. If you're not sure about this, make sure you watch the previous video in this topic. Let's start with this first question. What we need to do is find the equation of the line that passes through 0, 4 and 3, 10. The formula we saw a moment ago allows us to find the equation of a straight line through a given point with a given gradient. So what we have here are two given points, which means we could choose either of those, but we still need to know the gradient. Well, how do we find the gradient of the line that goes through these points? I'm going to demonstrate this using a diagram, but eventually what we want to be able to do is do this purely using algebra without a diagram. So here is the straight line that goes through the points 0, 4 and 3, 10. We can find the gradient by working out the change in y divided by the change in x. Using the diagram, we can see that the change in y is 1, 2, 3, 4, 5, 6. And the change in x is 1, 2, 3. 6 divided by 3 is 2, so that means we have a gradient of 2. Now that we've got a gradient, we can use the formula y minus y1 equals m multiplied by x minus x1. And we could choose either this point or this point to use for our x1 and y1. But actually we don't need to go to the trouble of using that formula, because in this particular case, we know the y-intercept of this line. We can see straight away that it is 4. That's the point where the line crosses the y-axis. So what we've actually got is a straight line with gradient 2 and y-intercept 4, which means the equation of the line we're looking for is y equals 2x plus 4. We don't have to go to the trouble of using the more complicated formula. In the next example, however, it won't be so easy. Neither of these points gives us the y-intercept straight away. So let's see how we would do that one. This time, I don't have an accurate diagram to help me find the gradient of the line that goes through these 2 points. But you can always draw yourself a very quick sketch. The point of a sketch is not that it's accurate, it's just something to help you see what's going on. Here I can see I'm going to need to mark a point that has an x-coordinate of 9 and another point that has an x-coordinate of 15. So I'm just going to put a 9 and a 15 down. It doesn't have to be very accurate, just get them in the right order, however. I also need y-coordinates of 20 and 28. So I'll put a 20 there, and 28 is obviously further up the y-axis. Now the points I'm actually interested in are, of course, 9, 20, which will be about here, and the other one will be 15, 28, which will be there. And this is going to make it easy for me to see what the gradient of the line through these points will be. That gradient is simply going to be the change in y divided by the change in x. And I can see that my change in y is going to be 28 minus 20, and that is just 8. And the change in x is going to be 15 minus 9, which is just 6. So that means I have a gradient here of 8 over 6, which simplifies to 4/3. Now, in the long run, you shouldn't even have to draw a sketch like this. What you should see that we're doing is simply 28 minus 20, that gives us the 8, divided by 15 minus 9, that's what gives us the 6. And we get our gradient. And in this case, it was a fraction that we could simplify from 8/6 to 4/3. We can now use the formula. Now for x1 and y1, it shouldn't matter whether we use 9, 20 or 15, 28. I'm just going to pick 9, 20 because those are smaller numbers to work with. So y1 would be 20, x1 would be 9, Substituting all of that in, I would get y minus 20 equals m, remember, which was 4/3, x minus 9. So that means I've got y minus 20 equals 4/3 x minus 12. All I've done here is multiplied out the right hand side. Finally, I need to add 20 to the left hand side and the right hand side to give me an equation in the form y equals mx plus c. I don't have space underneath, so I'm just going to write the answer to the side. The equation I'm looking for then is y equals 4/3 x plus 8. What we're doing in this video is very similar to what we were doing in the previous video. The only difference is that we have to work out a gradient for ourselves at the start using these two given points. After that, it's all the same, except we have a choice of which point to use in our formula here. It doesn't matter which one. So if you did use 15 and 28 for your x1 and y1 and followed through all the steps, you would still have ended up with y equals 4/3 x plus 8. In fact, it might be worth you pausing the video and trying that for yourself. For example C, I'm going to start you off and then let you complete the question for yourself. First, let's find the gradient. That's m, and that is going to be the change in y divided by the change in x. So I could do that as follows. I'm going to do the change in y, that's -4 minus 0, and divide that by the change in x, which is 3 minus -1, which gives me -4 in the numerator over 4 in the denominator, and that simplifies to -1. So my gradient is -1. Pause the video and see if you can complete the rest of this question. Here's one way you could have done it. I'm going to choose -1, 0 as my input for x1 and y1. That's because -1 and 0 seem slightly easier numbers to work with than 3 and -4. So my formula would look like this. Y minus 0 equals m, which is -1, lots of x minus x1, which is -1. Now let's tidy that up a little bit. Y minus 0 simplifies to just y. And on the right hand side, I've got -1, lots of x plus 1. So I'm just going to rewrite the bracket as follows. That's -1, lots of x plus 1. Subtracting -1 is the same as adding 1. Now multiplying this out, I simply get y equals -x minus 1. Let's move on to example D. Pause the video and see if you can just work out the gradient to start with. Hopefully you found that the gradient of the line through these points is 0. We've got a change in y that is 0. The difference between -4 and -4 is 0. That means, regardless of the change in x, we're going to end up with a gradient of 0. So we know we're looking for a horizontal line because that's what a gradient of 0 means. And we also know that the y coordinates of the points on that line are -4. So this is in fact just a line y equals -4. Now, of course, you could have used the formula and the values of m equals 0 and picking one of these coordinates to give you your x1 and y1. Using that formula, you should have got the right answer anyway, y equals -4, but you'd have done a whole lot more work than you needed to. So remember, keep your eyes out for shortcuts if you can. And in fact, there was a shortcut you could take in E, which hopefully you noticed. First off, hopefully you found that the gradient in the case of E was -3. But again, this time we don't need to go to the trouble of using a formula like up here because we can see the intercept, the y-intercept straight away is 7, we know that this line goes through the point 0, 7. So straight away I can write down my answer as y equals negative 3x plus 7. Finally, we're on question F. Now this time there's no nice easy shortcut you can take. Hopefully you found that the gradient was 2/5 and then used the formula with either of these points to get an answer of y equals 2/5 x plus 16. If you'd like more practice on questions like this, don't worry, you can. Scroll down to the bottom of the page and you'll find an interactive applet. This applet lets you generate as many questions as you'd like, and it also lets you drag down a slider to give you step-by-step guidance on how to answer these questions.